will be able to save a little time because my colleague Don and I didn't get a chance to coordinate last night because we threw Don on the panel at the last minute. So he and I have some commonly shared slides, so I'll go over those rather quickly or skip them. So for those who aren't in the area, Southern Cal Edison covers about a third of the state. And as Don said, we're actually considered an industry leader. We have the most effective or the largest energy efficiency program in the country. And we actually talk about that a little bit later as part of the success stories that Laura mentioned. We also, in terms of scale, are a fairly large, one of the larger utilities in the country with almost 13 million customers that we serve. From the challenges standpoint, as we'll talk about later also, we serve a very large geographic footprint. The couple of the utilities in California, including us, are enormous compared to some in other states with over 50,000 square miles, which has some implications on system stability and things like that. In terms of the topic here, I work on a different side of the company than my colleague Don, who's on the supply side in terms of the solar generation we get. I work on the demand side, so we have a program where we offer opportunities and incentives to our customers to put in self-generation like solar, wind, or fuel cells as a way to reduce their peak demand on the utility grid. We also have, as I mentioned a minute ago, energy efficiency, the largest energy efficiency program in the country, which is a way to reduce, again, demand. And then we have a demand response program, which is is very active and can be used to more quickly reduce demand on the grid, sometimes when we really need it. You may have seen in the papers recently, we have an extended outage at our San Onofre nuclear facility in Orange County, and that means we have a significant amount of lower amount of baseload generation available in our system right now. And one of the ways we're preparing to mitigate that, if we have a hot summer, is we would put in place additional demand response programs where we'll go to a large industrial customer or other customers and work with them to quickly reduce their usage of electricity if we have an issue or if we have a system peak that we're concerned about on a hot day. So this is quite a bit what Don already talked about, so I'm going to speed through it. But I wanted to point out something important in California. As you've heard a couple of the speakers mention, we don't just fly by night with these programs. We do have very formal, what we call in California utility speak, a loading order. And the loading order says, an objective for our state and for our ratepayers and our customers goes in this order. So you heard my colleague and one of the others talk about this. The very first thing we want to always do is energy efficiency, and the reason is because it's the most cost effective. I'm a solar and a renewables guy. I've done it for most of the last 25 years, but I will tell anybody that energy efficiency is generally more cost effective than anything we can do today on the renewable energy side. Okay. Also, as I mentioned, demand response here, the same kind of issues. Next in line, then we get to the larger scale renewable resources that Don was talking about, and so on down the line. Distributed generation, which this is there's a lot of flux, a lot of things going on right now with technology improvements to where we may see more of this distributed gen. And then sort of at the bottom of the pile is the ability to add new fossil-fired generation. In California, that means natural gas. We do not add any other kind of generation in California. But as a couple of the speakers mentioned, including LADWP, we may be adding more natural gas-fired generation to help us with the balancing issues and to help with some of the system stability issues as we bring on more renewables. Okay? And so here are the three things the utility planners always worry about. Number one, system reliability. We can't not have the lights go on when our customers need it. Resource adequacy, meaning are those resources, whether it's solar, wind, natural gas fired, are they going to come on when we want it on? Or when you come home and turn on your air conditioner, is that going to be available? One of the subsets of that, and one of our big challenges in California, is do we have the transmission capacity to get all that energy here? Unfortunately, as I said, we have 50,000 square miles. We have large amounts of solar out in the desert region, and all of us are here in the metro, the Southern California metro regions. To get that energy into the basin is tough, and I guess to be honest, we all live here in California. We all know how hard it is to build anything. It's particularly hard to plan and build transmission lines. So to bring new transmission capacity into Southern California is a big deal for us. This is important. We're on the fourth year of a pretty tough recession for most of our customers. Our customers, just like everybody's, concerned about their rates. So when we look at resources, whether they're large-scale renewables in the desert or whether they're smaller-scale renewables or anything else, we have to be concerned about the cost. What's the cost basis for that resource, but also about the risks. So somebody in Don's group gets to look at the terms of these contracts, not just how low a cost is it, but is this a reasonable risk for us as a utility to take on? And then, of course, the environmental considerations that all of us are concerned about and that our state policies and goals are targeting. We're going to lower our greenhouse gas emissions in California. That's a stated goal, and these renewables will help us get there, as well as I said, energy efficiency is always a way to keep pushing the envelope to do that more. So here's Don's slide. This is actually 1 year earlier, and I actually left it in here now on purpose to show you. If I had tucked Don's slide next to this, there was a significant change from 2010 to 2011. So I put it in here to point out something, and that is, as he and our gentleman from LADWP mentioned, it's pretty tough to hit a moving target. You're looking at things in the future, and in the meantime, that airplane, to borrow his analogy, that airplane is flying at 40,000 feet, and we're trying to change the motor, change the jet engine or something. So the planning's harder than it sounds. When we're talking to the public, we often point this out right here. If I ask non-utility folks, if I ask public people, what do you think the biggest part of our California renewable resources are? The answer almost always comes back solar. The answer in California, as you've seen several times now, is geothermal. We're blessed with geothermal resources in Northern California around Geyserville, out in the Nevada desert along the California border, and then down in the Salton Sea area of Southern California. We have significant geothermal resources. Many of the plants out there, by the way, are fairly old, so it's possible in the future there could be more technology. I worked on a geothermal plant almost 30 years ago that's still running in the Salton Sea region. But as he pointed out, the hydro is kind of locked. You're not going to see that increase as a percentage of our totals. Wind is a big deal in California and has gotten a lot of press. Wind today, though, is fairly location specific, and unless some of the technologies and the economics change significantly in the next few years, it'll probably stay that way, and that leads to what Don and Mr. Aram from LADWP said. By far our largest growth rates are in the solar area, having to do with both the technology increases and the economics of it. So real quick, at Edison, we actually have three kinds of programs for our customers for solar. Number one is what we call the small program, and this is where the one that I'm responsible for, where our customers, whether they're residential or non-residential, can put solar or other technologies on their homes or businesses. We pay them an incentive. Those are limited in size to a maximum of 1 megawatt, and also limited in some other ways, but in aggregate, they're quite large. So today, we have close to 300 megawatts of these systems installed already, with another 100 megawatts in the pipeline, and we'll have close to over 900 megawatts just in that program alone by the year 2016. So fairly big numbers in aggregate. The second one, as you saw earlier, we own some assets where the utility, SCE, owns rooftop solar. 125 megawatts of that is us installing it and owning it. The rest is, some of it's contracted out by Don and some's contracted out in the rooftops groups, but both of those through third parties. There we can take advantage of the economics of and market competition, and in fact we saw that in the last year where we got very competitive pricing from third parties. And then the largest scale, and the one that contributes far and away the most, anywhere from 5,000 to 7,000 megawatts, I think, and stealing one of Don's numbers, is here in the main power procurement program. So here we have the lowest cost per unit and the largest amount of solar energy, not without its challenges. Again, its challenges, number one being transmission access, number two there's planning and land use issues, which a couple folks have talked about, and number three, in terms of the risk, there's always a question about how many of those contracts and customers will be producing. As a utility, we still have to have the energy available. We can't risk that. So here's the three programs, again, kind of our comprehensive approach, in this case to solar, and I'm using solar as a proxy because the other technologies are nowhere near as big. Again, the large scale stuff that we just talked about, we have a number of different contract mechanisms. The medium, what we call medium, which is the utility owned, these tend to be 1 to 2 megawatts, and they can be in and around the metro areas, whereas a lot of these tend to be out in the desert regions. And then true distributed solar, we call them small, going up to 1 megawatt. They are in and around our service territory. Today we have these in about 200 different cities in Southern California. The advantage here is that these don't require transmission. They are reducing the demand right where it's needed. The disadvantage is they're much more expensive. And then there are some unknowns on the challenge side, and that is if you had a high concentration, because our customers are like everybody else, they don't, my customers aren't average, right? They're just like you or I. They do what they want to do. So we may have a very high concentration of solar customers on one block in Santa Monica, or one block in Santa Barbara, or one block in Palm Desert, and much higher than our average. So Don mentioned, so far we haven't had big issues because our numbers overall are small. We have about 4.9 million customers, and I have about 30,000 solar customers, but we're adding 1,000 to 2,000 a month. So at some point in the future, we need to know, is there going to be impacts at some point in the future? And so our technical folks in the transmission distribution side are doing a lot of studies to look at that challenge, meaning, if I had 27 solar systems on one block in Santa Monica, would it have an unstable effect on the local grid there or not? And how might we deal with it? So Don mentioned this real quick, but again, an illustration visually of the largest growth in the past. Some of you folks, Californians here, know this. When we talked about solar 10 and 20 years ago, we were talking about solar thermal. There's some solar thermal power plants out at Ridgecrest area in the high desert that have been there for somewhere around 25 years now, maybe longer. But almost all the new assets that we've been putting in and contracting for are solar PV, including these large-scale solar PV ground-mounted systems where some economies of scale have kicked in. There was a lot of learning in Europe where the solar industry that received very high subsidies and as a result put in mega-sized projects, but they did learn some things about installation pretty well. So I'll skip over this because he talked about that. This is the customer-owned solar that I was just talking about. And then this is a good chart to start an argument. So my friend Cecilia and I like to argue over this, as do other people in the renewable industry. This is from a global consulting firm, and it's tracking the historic drop in solar pricing, and more importantly, trying to figure out what does that mean for coming years. And so this chart is predicting continued declines for these reasons. Number one is there's lots of stuff going on globally. We like to talk about California like we're a big deal, but we're actually still a fairly small part of the global solar market. Number two, there's some production economies of scale and some technology improvements that are very impressive from the big manufacturers, companies like a couple of my colleagues here, as well as some of the other global competitors. The price has been coming down steadily. There is some debate about can it continue to drop at this rate or go faster or slower. And in fact, this particular chart I need to update because the drop in the year 2011 was actually significantly greater than what I showed here. So I need to update this. So in real life, we're down around here already. So it remains to be seen how fast it'll decline, probably not continuing at the rate it did in 2010 and 2011. But the more important question is long term. How does it decline, and how does that compare with, for example, what we call incumbent energy costs or utility energy costs? So, so here's kind of my summary of what I was talking about. As we get into higher and higher levels of renewables, there's a lot of unknowns. It's not necessarily all bad, but there's a lot of unknowns. And number one for us as utility guys is grid operations. How do we make sure the lights come on every time? How do we accommodate things like the swings? As Don mentioned, when a large solar plant comes online or when a gust of wind picks up a wind farm, there are a lot of technology improvements coming to bear that'll help with that. both with sort of reliability and the predictability. A biggie that I don't have time to go into here, but we could talk about later, and one of my colleagues will talk about, is energy storage. Energy storage is near and dear to the hearts of utility folks. For example, all of our solar resources hit their peak at solar noon, or roughly around that time, 12 or 1 o'clock, depending on the time of year. We're what's called an afternoon peaking utility. Our customers use the most energy between 5 and say 7 p.m. depending on the time of year. If we could store some of this renewable energy for just a few hours and shift it over, that's a big deal economically and from a reliability. Number two, the challenge, as I said, is resource costs. We have lots of mandated programs in California, and they do add costs. It remains to be seen, you know, politically and from a customer standpoint, how much of that is acceptable. But as a utility, our mandate is always keep the ratepayer costs as low as possible and still meet those mandates. As I said earlier, we have lots of issues in California with transmission. We have other issues with what we call interconnection, a technical term, but our process of making sure a customer with a solar project can safely connect to our utility grid. And right now we have hundreds of these. Trying to go through engineering studies, we have to make sure they're done safely, but it's hard to get them done fast enough. And then, of course, environmental issues, and I use the phrase nothing's perfect. As some of you guys know, there are always trade-offs. Anybody who tells you otherwise is fooling themselves. So when you hear about somebody's putting a large-scale solar project out in the desert, solar or renewable energy advocates are happy, but maybe somebody else is not happy because we're building on a site that has tortoises there or something. So there are no generation resources really that have no impact. Nothing's perfect, and as a society, people just have to figure out. And this is an illustration, by the way, of what Don was talking about. A simple example, some of these plants are huge, and they can cover, you know, we have some plants, there are some plants that are upwards of several hundred megawatts. They cover a huge area. They can also have some significant variability in them if you had cloud cover passing over. As you heard two of the speakers mention earlier, sometimes you can have sort of an averaging effect because you have generation spread over a wide area, wind over here, solar over here, but sometimes not. So I think for the foreseeable future, we're going to need to have significant backup generation, primarily clean natural gas-fired generation that can start up like that instead of taking 2 to 3 days like an old line power plant. Storage is a big deal, as I said in the last thing, but today it's not really technically or economically feasible. Edison has several energy storage demo projects going on right now, one on a large scale. I think it's like an 8 megawatt level battery storage looking at wind energy, and then also on a small scale looking at distributed solar down in Orange County. So I am done, and I have some appendices for later if anybody has any questions. So.
Yeah, I think we have a little time for questions before the next presentation. Thanks, Gary.
I have a question about this. I didn't understand correctly when you said if it's a concentration of customers that they have solar. What is the problem? I didn't understand.
So the concentration question has to do with the ability, you know, the utility grid systems are built to go one way originally, and now we're looking at operating them in 2 directions. So if you had a series of homes that had all had solar on them, they can be producing more energy than that circuit is normally designed to handle, or than the local switching is designed to handle. So we have a number of studies trying to review that. The solar industry, by the way, is doing the same thing, looking at inverters and other devices to see if they can provide some sort of information and ways around that. Also in the utility world, we are going to what people call AMI, or smart metering. The smart meters may give us some additional information to help that too. On an individual project basis, we can mitigate it. We do a study to say if this new solar project goes in on this roof, can the local circuit handle it if all of a sudden that 100% of that output is being pushed back into the grid, okay? So we do a study, or we'll do a quick analysis on all projects like that. But what we haven't had a lot of experience with, as the earlier speaker said, is what happens when you have a whole bunch of those at once. you know, we don't want to be overly cautious, right, and try to design for the worst case. But as a utility, we tend to have to design for the worst case. We can't have a circuit go dead. There are also some technical issues related to safety, as most or some of you folks know. When a utility circuit goes down for any reason, those solar systems turn off. And there's a reason for that. There's a safety reason, but there's a lot of questions and issues related to, well, how do we manage the process of getting a bunch of them back on if that circuit comes back to life and it happens to be in a neighborhood in Santa Monica where there's a lot of solar, okay? So mostly it's just that we don't know, honestly. We haven't had much experience. In the US, the state of Hawaii has the highest penetration, is what we call it, of solar in certain neighborhoods and circuits, and not for any magic reason, but energy costs are very expensive in Hawaii, so renewables have had a much greater level of penetration there. So there's some very interesting utility studies going on in Hawaii that folks may be able to learn from. We're also part of several national teams through the US Department of Energy NREL, or National Renewable Laboratory, who's studying the exact same questions. Yeah.
Any more questions for, yes, over there.
I heard that there's some battery technology. Of course, one of the problems with solar is that its effectiveness is you lose it at night, right? And same with wind energy, is that, you know, it's not as reliable as some other sources that you guys have used. I had heard that there were some innovations in battery technology that were going to make that storage issue less moot. Is that just people making things up to me?
I wouldn't say that's people making things up. I would say that's generalization and forward thinking, right? So indeed, there's a lot of technology. You know, our battery storage technology has been lead acid, the same one that's in your car and everything. Now we have a lot of experience with lithium ions, which came out of EVs and also out of laptops, right? There's a next generation lithium ion battery technology that's undergoing a lot of testing right now, but the truth is none of them are to the point yet where they're market scale, they're economical, they're well tested. Not to say they won't be, but they're not today. So as I pointed out, we have a project here in Irvine where we have both solar systems and batteries on a number of homes, and that's exactly what we're trying to test. I don't think I have it here, but we have a large scale one out in the desert, and where we're testing different projects, different kinds of battery technology, but honestly none of them are ready for prime time, to use somebody else's phrase. The other issue is in most states, and chicken and the egg thing, there aren't a lot of incentives, nor is there a pricing mechanism to reward the use of energy storage like there is for generation. So naturally enough, there isn't a huge market for it, so there's not a lot of development. But everyone thinks there will be, it's just no one knows the answer. And by the way, it may not be battery storage, it might be flywheel technology, it might be other methodologies too, compressed air storage, they all have their pros and cons. No one's very far along the path though, and today people are betting, probably the sort of the midterm, if you will. The auto industry is putting billions of dollars into next generation lithium ion batteries for the EVs, which hopefully that technology then could transfer. But today it's pretty rudimentary. It's not. It's just not very widespread. It's certainly not economical on a utility scale, which is what most people are talking about. Will we get there? Probably will, but it may be a while. I threw this slide up here, by the way, to illustrate something you heard earlier. This is a colored pie chart of the different states, and somebody said California is the big deal. It certainly is. Look at the size of some of these renewable energy contracts under contract compared to the other states, in aggregate. California sort of dominates, which really has a positive effect on the markets.